Yeah, this is a fascinating topic. Whoever solves the problem is almost certainly going to get the Nobel Prize, because we've no idea what this dark energy is in the universe that's making it expand at a faster and faster rate. Basically, something is pulling the universe apart. We've just given, all the best we've done is give it a name, dark energy, and measure it, but we have no idea what it is. And the dark matter we've known of for even longer, and that's some substance in the universe that it makes it far more than all the atoms that you and I are made of, whether they be in stars, planets, or gas clouds unseen. So there's between those two, there's about 25 times more stuff in the universe than we're aware of, than those planets and stars are made of. So, in this stage of the 21st century, our knowledge of what makes up the universe is worse than ever.
It's mad when you really think about it like that.
It feels kind of equally exciting and scary at the same time, because as you said, it's pulling the universe apart, which sounds a bit daunting and intimidating.
Yes, I give a talk about the universe, and we do a lot in schools around the country.
Cool.
And we end the talk on a bit of a downer, in that it looks like the universe is going to expand forever. In fact, it's going to expand so quickly that right now, people probably have some idea how small one atom is. They're incredibly tiny. And you'd fit 10 million of them across 1 millimeter on your ruler.
Wow.
But your house, actually, the space that's sitting in, the front wall moves away from the back wall about the width of one atom every year.
Really?
So space is stretching, and that's what's happened since the Big Bang. But we now know that that's speeding up. So it's eventually going to be, a long time in the future, it's going to be 2 atoms a year, and then 20 atoms a year, and then 1 million atoms a year, and then trillions and trillions of atoms a year. Eventually it'll be doubling its size every year, and then quadrupling. It's increasing by a factor of 10, and one day in the future, the space in the universe will be stretching so fast that individual atoms will be ripped apart, and nothing will be able to exist in the universe. And as far as we know, that's the scary death, if you like, that awaits the universe a very, very long way in the future, much longer than the universe has currently existed for. But this is why we're so interested in dark energy. Maybe at some stage it stops or it turns around or does something else. But if it keeps on doing what it's doing now, that's the fate of the universe.
Wow. That's unreal. And the fact that, as you said, in terms of the example you gave there, where like your front wall and your back wall are moving away from each other at about the distance of an atom per year. So it's one of those things where it sounds like this big, massive thing that's going to happen in the future. But the fact that we have like evidence that we can show that, look, it is happening. It's not a theory. It's not something we think is happening. We know it's happening. It's crazy.
Yeah, on the scale of small objects like houses, the expansion of the universe is trivial. And things happen, earthquakes that dwarf that, and we move in and out of the house all the time, so our own motion is far more important than the stretching of the space that we all sit on. But, we know from dark energy that's going to increase, and that's sort of a good way of putting it into context, putting it in people's minds. It also explains why, we needed 21st century technology really to find it. It was found just at the end of the 20th century, and it was found by looking at very distant galaxies. So you can imagine how many houses you would fit between here and a distant galaxy, and each one of those will be moving away at 1 atom per year. So you've got trillions of trillions of trillions of houses in between. The rate actually becomes kilometers per second, not just 1 atom per year.
Wow.
And we're able to measure that using spectroscopy. So this is why we know it's very real and very measurable. In fact, it's relatively easy to measure compared to how difficult it is to explain.
My mind's blown here. I don't mean to be so quiet, but I'm just speechless. That's amazing and scary, but also it's so amazing that that it is measurable, that this is technology that we have. And as you said, that we've needed the 21st century technology to enable all this, but wow. Yes,
and it is mind-blowing, and the problem is it's a very real effect that's happening in our universe. And it's scary in that why does the universe exist if it's just going to basically destroy itself at some
Yeah.
stage in the future?
And what happens after?
There's any reason?
Listen, I suppose that's the question.
Yeah.
It's kind of another angle coming in at that question of why are we here? Why is the universe here? Why does it exist? And I suppose there may never be an answer to that question. I suppose why does the universe exist? It kind of exists because it exists.
Yeah, we may never know the easy answer to that particular question. Why? Because why is a difficult one to answer.
Yeah.
There may just be no reason. It's just to do with the laws of physics, laws of nature, and it may be that this is one universe and a whole multiverse of universes where things are different in each one, and this is the only one where life could get formed and ultimately become self-aware. But then, what is consciousness? How can matter in a crazy universe like this become aware of itself? And that's a tough question, but the leading minds of the world are working on this and trying to understand that we've learned in the past, never say never. Somebody might figure out the easy way of explaining it.
Yeah.
And they'll be the next Einstein or Newton, because it is a huge topic of research amongst astronomers. Definitely Nobel Prize stuff.
Yeah, that's the thing. It's going to be the big. It is the big question. It's the, as you said, there's definitely a Nobel Prize in the future of whoever kind of works this stuff out. But when we're talking, sorry, go ahead.
Yeah, Saul Perlmutter is his name, won the Nobel Prize for discovering this dark energy, the fact that universe expansion is accelerating and not slowing up, and everybody had thought. So there's already been one Nobel Prize won in this area.
Wow. So it's wide open without a shadow of a doubt.
Plenty more opportunities.
But that's, as we said, that's the effect of dark energy. We also spoke about dark matter, and you talked about that it makes up so much of our universe around us. It's in the 90 odd percent, isn't it?
Well, it's about in terms of the atoms and that make up you and I, the planets, the stars, the stuff we can see. Either it's glowing like a star, or else it's lit up by a star, like back to planet Earth. So that stuff is ordinary matter, but there's this dark matter stuff, and there's roughly about 5 times more of it than there are atoms, and we have no idea what it is. Now, it's going to be, we think, a bit easier to explain than dark energy because, first of all, we can measure it much more easily. There's definitely a lot of it controlling our galaxy, the Milky Way, and lots of other nearby galaxies as well. And it's crazy stuff that it's like light, that would, but to dark matter, everything in the universe is like glass. So the light can pass through glass very easily.
Oh, I see.
And so it is, dark matter could pass through the Earth, it could pass through the Sun, pass through anything, and it seems to mostly inhabit out in the outer parts of galaxies, probably because it's in orbit about the galaxies, and that's where it would go slowest. So it spends most of its time out there, and that makes it control the rate at which the galaxy spins. And galaxies should spin fast at the center and slow at the edges, a bit like water going down a plug hole in a sink.
Yeah.
But it doesn't. It spins at the same speed, and the only way of explaining that, why the outer bits move at the same speed as the inner bits, is that there's something out beyond that that's much more massive that's controlling the way the galaxy spins. And that was found a long time ago, and we think, well, people used to think, it's probably just unseen small stars. No, it isn't. Maybe it's myriads of planets, but how could that be? We're pretty sure that just doesn't make sense. And the best theory is that it's a new type of subatomic particle. I mean, we might have things called neutrinos that pass through the Earth, no problem at all. They can pass through the Sun. We've been able to trap a few of them and prove that they exist. So neutrinos are crazy little subatomic particles, and we think maybe there's another subatomic particle, the dark matter particle, and that's what they're looking for at places like CERN, the Large Hadron Collider, at the moment. They've already found the Higgs boson, so maybe they'll find this dark matter particle, and that would tie it down and give us a huge insight into what is really out there. But if it's not that, scientists are going to be scratching their head over something that is a form of matter, unlike dark energy, which is just really a force pulling the universe apart. Dark matter is some form of matter, and we have no idea currently for certain what it is. But there are other theories as well that maybe it's something to do with the laws of gravity and they need adjusting in the same way that Einstein adjusted Isaac Newton's laws of gravity and gave us a better way for understanding things at very high speed. is relativistic effects, as they're called.
Yeah.
Einstein's theory of gravity is very similar to Newton's. As long as things are moving slow, they're actually identical. And things start moving close to the speed of light, Newton's totally wrong, and you need Einstein's theories of how things work. And it may be that there's another tweak on top of that for the very large-scale universe that can somehow explain either and dark matter and dark energy. And that's really the cutting area of research, and that was the subject of our New Year public lecture.
And we'll get on to that as well, as you said, with the public lecture, because for people who missed it, there is an opportunity to see that again. We'll get on to that in just a second. I just wanted to ask really quickly, though, we're talking about that and talking about dark matter, and as you said, we don't 100% understand what it is yet. And is it kind of one of those situations where we say it exists, or we know it exists, kind of literally because there's like a necessity for it? It has to exist. There's something there. We know it's there, we just can't quite put our finger on it. Is that sort of where it is?
Yeah, with dark matter, the classic experiment that discovered it was that you look at a distant galaxy, and using spectroscopy, you can see that the left edge, say the galaxies are large flat disks, and let's say suppose you're not looking at it from above or from the edge, you're looking at about halfway. So the left edge may be coming towards you, and if it is, then the right edge will be going away from you.
Yeah.
And the light from the stars in those edges, you can measure with a spectroscope and figure out how fast they're actually moving. It's a great little trick that physicists have. And it works extremely well. Now, you can measure the very edge of the galaxy, halfway from the center to the edge and near the center, and you would expect from, if you do the mathematical calculations, the stars in the center, they're close to the center of the galaxy, they'll be going around very fast. The ones out at the edge will be moving much slower. And that's not what people measured when they first did it. They were a bit shocked. Now they thought, there must be just some unseen gas and dust or something else in the galaxy, because what else could it be?
Yeah.
Nobody thought there'd be any crazy dark matter particle. But it became obvious as telescopes and astronomy became better that there aren't faint stars or unseen planets floating around in interstellar space. And so it had to be something exotic outside of the galaxy. So the real picture of a galaxy is the atoms, stars, planets, gas and dust spinning around at much the same rate, rather like a car wheel, a solid wheel. And then out beyond that, there's 5 times more stuff that gravity is actually affecting the inner stuff, because it isn't solid like a wheel, it's individual particles, but it's been forced to move like a solid wheel by this stuff further out. And stuff is the best description we have for dark matter so far.
It's all just so fascinating.